All right, next up on our EAS reactions is a Friedel-Crafts alkylation. So this reaction overall is pretty cool. One of the coolest thing about it is that we now have a carbon-carbon bond formation reaction. So if we want to synthesize larger molecules, we often have to have carbon-carbon bonds, and this is one way to do it. So what we're going to do here is we're going to have our benzene ring. To it, we're going to add some sort of alkyl halide and then a Lewis acid catalyst, in this case, aluminum chloride. That's pretty much going to be the only one we use. Right, so that's our Lewis acid catalyst, our LA-CAT. And what we're going to see here is a substitution reaction where we've now added our alkyl halide onto our benzene ring, right, in just the alkyl form. So we get rid of the chlorine. So the first step, as all of these reactions that we've learned, is first we need to activate our electrophile. So in this case, what we have is our chlorine having one of its lone pairs attack our Lewis acid catalyst. That gives it a positive charge. And then at this step, it varies what kind of alkyl halide you have. If you have a secondary or a tertiary alkyl halide, you can go ahead and kick this off completely to form a carbocation. If you have a primary alkyl halide, we'll see that later, but you cannot form a primary carbocation. And as you can see, we've made this more electrophilic because we have a full-on positive charge on our electrophile. In case you're wondering, why are we using aluminum chloride? The answer is pretty simple. It has a empty p orbital, which we can then donate our lone pair into, right? So that's the reason it can act as a Lewis acid catalyst, because it has an empty orbital that can accept electrons. After we form our activated electrophile, the rest of the reaction is pretty much the same as we've seen. Our nucleophile, our benzene ring, attacks our electrophile to form our sigma complex. And then we regenerate our catalyst and deprotonate our benzene ring to reform the aromaticity. Again, make sure you're plucking off the correct proton. And then you have HCl and your catalyst regenerated, ready to act again. Overall, this looks like a really cool and exciting reaction. Unfortunately, there are some severe limitations to it, which we'll learn about in the next video.